Hi everyone, I am Yamini, Department of Computer Science and Engineering, SNS College of Technology. Today we are going to discuss about graph definition and application of graph. This topic comes under U3 graphics in data structures. Before we begin, let's recall what we have learned so far. We know that data structures can be broadly classified into linear data structures and non-linear data structures. In linear data structures like arrays and linked lists, it is stored directly in a sequential order, while nonlinear data structures like tree and then graph represents data in a network form. Here, what we will be covering today, that is graph basics, different types of graphs, why graphs are important in the real world, their application, and finally how to traverse through them efficiently. Next one, so what exactly in a graph? A graph represents a relationship among data items. It consists of a set of vertices and set of edges connecting those vertices. In mathematically, a graph is defined as G, that is G means graph, and pair of V and E. V means vertices, E means edges. This is for vertices 1, this is for vertices 2, this is edge. Next, why graph? In real world problem, everything is connected. City connected by roads, people connected by social network, and computer connected in networks. City connected by roads, social network, and computer connected by networks. Graph are the perfect way to represent each connectivity. That why understanding graph helps us model real world system efficiently. Next one, graph terminology. Let's get familiar with some basic terminologies. First one, vertices V, edges E. Next, in degree, out degree, in a degree topic, and path, and then cycle, connected graph, and then subgraph. First one, a vertex. A vertices are node in a data point, and edges represents a link between two vertices. We also have degree, in degree, and out degree, which tell us how many connections a vertices has. Then we have path, cycle, connected graph and subgraph, all of which describe different graph properties. Next one, that is a core needed identified. In some terms, graph helps represents a real world entity like cities, people, and services as a node, and their relationships such as a road, friendship, and then data links as a edges. We can then use algorithm to find the shortest path, optimize route, or manage a dependency. Next one, path and then simple path. A path is a sequence of nodes connected by the edges. Each node appears only once. We call this a simple path. For example, a path V2 to V5 without repetition is a simple path, every useful in problem like router finding. Next one, degree and then in degree and then out degree. In a degree of a node is the number of edge connected to it. Next one, in degree. In degree is a counted only incoming edges. In out degree is it is connecting outgoing edges. Next one, types of graphs. There are so many type of graphs. First one, directed graph. Next one, indirected graph, weighted graph, unweighted graph, cyclic graph, acyclic graph, and shapes graph. In directed graph has edges with directions like think of one-way road. Next one, undirected graph has edges without direction like two-way road. Next one, weighted graph assign value like distance or cost to the edges. Next one, unweighted graph only shows connection. Next, cyclic graph and acyclic graph. In cyclic graph and acyclic graph depends on whether cycle exit. And the shaper graph means a graph has a few edges while a complete graph connected every vertex to every other vertex denoted as k of n. Next one, let us apply this Suppose we need to find the shortest path in a transportation network. We represent a city as a node and a road as a weighted edges. We can apply Digista's algorithm or for Bellman-Ford algorithm to solve this efficiently. Next one, prototype. In prototype, we test this algorithm for most shortest path problem, Digista's algorithm, and better than the Bellman-Ford algorithm due to its efficiency in handling positive edge weights. Next one, application of graph. In the application of graph are everywhere in computer networking. They are used in a routing algorithm. In social networks, people are vertices and friendship are edges. Next one, Google Map, cities as a node from a weighted graph. Biology and chemistry graph model molecular structures and protein interactions. Thank you.